Lesson 1.3 is on comparing and ordering real numbers. So we're going to look at them, see which one's bigger, which one's smaller, or if we have a whole group of them, we can put them in order, least to greatest, stuff like that. So question is, how can you compare and order rational and irrational numbers? If we look on page 19, it says Courtney and Malik are buying a rug to fit in a 50 square foot space. Which rug should they purchase and explain? So we talk about trying to get this to fit in a 50 square foot space. First, we need to think about what it is that that's referring to by it being a 50 square foot space. So when we see square feet, that is telling us that we're looking at the area. Square feet's dealing with area. And so we need to go back and remember how it is that we find the area of something. Looks like we have two potential shapes here. So two of the rugs are rectangles. One's a square, but we'll call it technically, could be a rectangle. It's a specialized rectangle. So the area of a rectangle is length times width. So what we can do is look at these different shapes and see what their areas are. So if we look at that first one, length times width, we could do 7 times 7, which is 49 square feet. Going back to the problem, it says we have a 50 square foot space, so 49 is less than 50, so that one looks like it could work. I'm going to skip over to that last one since it's also a rectangle. So 6 times 8.5. Rather than writing as 8.5, you do have the option of putting 8 5/10, 8.5. Especially depending on the situation. If we're allowed to use calculators just to quickly compute something like this, that'll make it a little bit quicker for us rather than having to change to an improper fraction and all that stuff. So multiplying those together, we should get 51. So that's 51 square feet. We're trying to fit this in a 50 square foot space, so that looks like that's going to be a little bit too big for the space that we've got, unless we want the rug going up the wall or something. The other option is this circular one. The circular one, area of a circle is pi r squared. And r is standing for the radius here. So if they tell us that the diameter is 8 feet, the radius would be half of that. Remember, the diameter goes all the way across the circle, radius goes halfway across. So half of 8 would be 4. And so we're doing pi times 4 squared. So if you were using a calculator, your calculators have a pi button on them, so you could do pi times 4 squared. If we had to, we could kind of estimate this, just kind of working it out by hand a little bit. And if we work that out, that doesn't come out evenly, so we'll say about 50.3 square feet. That's more than 50, plus most rooms I've been in are rectangular, not circular. So, if our area of our rug's more than the area of the floor that we're going to cover, plus the room's rectangular instead of circular, we're going to have different spots where the rug would probably be going up the wall here as well. So that's probably not going to work either. So probably the best choice then would be the 7 foot by 7 foot rug in this problem. look at example 1. Darcy wants to add the ribbon shown along the diagonal of the rectangular flag she is designing. Does Darcy have enough ribbon, and explain? So here's the flag. She wants this ribbon here to go along this diagonal. So seeing if she has enough ribbon, what we would want to do is try to figure out square root of 74, about what that is. And even without a calculator, hopefully we can think this out a little bit. Square root of 74, it's between a couple of perfect squares. Square root of 64, which is 8, and square root of 81, which is 9. So it's between 8 and 9. Our ribbon we have is 8.5, so that's between 8 and 9 also. So the question is, is that long enough or not? Well, what we can do is look at how far 74 is away from these. So 64 to 74, that's a difference of 10. Okay, we're ignoring the square root sign for the minute, just looking what's underneath these. 81 minus 74 is 7. So one's 10 away, one's 7 away. The one that's 7 away then would be closer to our actual number, which means that square root of 74 is greater than 8.5. If it's closer to 9, means it's, 8.5 would be right in the middle. Closer to 9 means it would be bigger than 8.5. So if it's bigger than 8.5, our diagonal is bigger than 8.5, our ribbon is 8.5, then we don't have enough ribbon. The book is actually doing a little bit more work than what they need to here, because on this next part they're saying, let's find a better approximation. So let's figure out to the nearest tenth what it is. Well, if it's over 8.5 and I've got 8.5, I don't have enough, period. So really, we don't really even need to do anything with what the book's doing on this problem. So try it says, between which two whole numbers is the square root of 12? I'm not going to worry too much about this first part. I don't really think we need that first line there. What we're going to do is we're going to try to find some perfect squares that are close to 12. So we have square root of 12. That would be irrational. That's not going to come out evenly. Let's think of something, a square root of something close to 12 that would come out evenly. So one perfect square that would be close to this, 4 times 4 is 16. So we can put this would be the square root of 16 here. That's a little bit bigger, so that's why we're putting it on the right side, because square root of 12 is less than the square root of 16. So square root of 9 would be just a little bit smaller. 3 times 3 is 9. At that point, what we're going to do, the next line here, is we're just taking the square roots of those numbers we just put in. So like we mentioned, square root of 9 then would be 3. Square root of 12, or sorry, square root of 16 would be 4. So it's in between 3 and 4. Okay, so if they wanted us to write it out, we could say it's between 3 and 4. Technically, we could figure out which one it's closer to. The difference of 12 and 9 is 3. The difference of 16 and 12 is 4. So it's just slightly closer to 3. It's a little bit closer to 3 than it is to 4. Okay? So, and you could verify that if you did square root of 12 on your calculator. You should get 3 point something, and the something should be less than 5. Okay, should be less than 3.5. It's a 4. Okay, good. In this case, like I said, though, they just asked what whole numbers, was it in between? So for this problem, between 3 and 4 is good enough. So look at example 2. They want us to compare square root of 32 and 5.51326 and so on. And then they want us to plot the numbers at their approximate locations on a number line. So the first thing they did, kind of like what we did in that try it just a minute ago, we're gonna figure out about what this is. And like I said, I normally probably wouldn't start with that first step, what they're doing. I mean, it's kind of like, you're not gonna just randomly pick these two numbers probably. I mean, it's fine, but I would just start with the second line. So thinking of some perfect squares, square root of 32. So we know square root of 25, which is 5, is a little bit smaller than that. Square root of 36, which is 6, is just a little bit bigger than that. So it's between 5 and 6. And again, we could look at these and see how far they are. See which one it's closer to. So the difference of 32 and 25 is 7. The difference of 36 and 32 is 4. So you can see it's between 5 and 6, but since this number is smaller, that means it's actually closer to 6. So it's between 5 and 6, but it's closer to 6. Okay, and that's helpful to know. The problem is our decimal, that other number, that other irrational number, is also closer to 6. So now we've got to pinpoint it a little bit better. So what they did is they multiplied some decimals together. So they said, well, 5.5 times 5.5 is 30.25. 5.6 times 5.6 is 31.36. We have the square root of 32, so it's more than 5.6. That's really enough for me to tell already what's going to happen, because the other number I had was 5.5 something. If our other number is bigger than 5.6 something, it's definitely bigger than 5.5 something, okay? So at that point, I'm really done. The book goes on to look at, well, 5.7 times 5.7. We don't really have to go to that point. We already know from that point that the one's bigger. I guess if we're trying to pinpoint this, though, I'll take back that statement a little bit. If we're trying to pinpoint it to the nearest tenth on a number line, it is good to do what they did there. 5.7 times 5.7 is 32.49. That's a little bit bigger than what we have, so we can put that square root of 32 in between 5.6 and 5.7. The other one, I'm not sure why they seemingly put it right on the 5.5. It would be just a little bit to the right of that. I would put it maybe like right here or something. So if we look at example 3, they have given us a set of numbers here. They want us to compare these, put these in order. If we were going to do a problem like this, putting all these numbers in order, I would allow you to use your calculators, okay? If we had enough time, we could do it by hand, but so pi squared, you guys actually, on your calculators, you could put in just pi, the pi button, and squared. They did 3.14 times 3.14. That's pretty close to what it would be anyway. And then, like if you use your pi button, you'd get 9.869604401. Okay, that's pretty close. 9.5, you know, is the same as 9.5. 9.8 is already a decimal. 9.5 repeating, we can just put a bunch of 5s after that. And then square root of 94 is like 9.695 something. The book just put 9.7. But the idea is, if we get all of these as decimals, once we get them as decimals, then we can put them in order from least to greatest. So what we can do is just compare the tenths place and then kind of go from there. So like if we're looking at these numbers, the lowest tenths place we have is a 5. Well, we have 2 of them that have 5s. How do we know which one's smaller? Well, look at the next place after that. The next place after that, that one doesn't have anything, so that'd have a 0 there. So this actually would be our smallest number out of this group. And that would be right on the 9.5 if you look at your number line over to the right there. The next one's just a little bit bigger than that. Okay, so 9.5, 9.6 something. Technically this one, if we don't round it off, is 9.6 something. It's just less than 9.7. So this would come next. And then 9.7 something, 9.8 something. This one's exactly 9.8, so it'd have a 0 after that if you want. And then this pi squared actually would be the biggest number out of this group. Once we've got them figured out in order, then if they ask us to, we could put those on a number line, and that's what they did here. Once again, some of their stuff, like that square root of 94, it's technically less than 9.7. I would put it right there. Okay, not right on the dot. Otherwise, I think they're okay with what they did. So on the try it, they want us to compare and order these numbers. One thing different on this problem than the previous problem is we do have some negative numbers. So you guys know negatives are smaller than positives. So if we can just get some of these that don't have decimals, those first 2 are the only ones that don't have decimals. Let's get those to being kind of a decimal or decimal approximation, and then we'll be able to put these in order. So square root of 11, if you do that on your calculator, it's like 3.31 something. 2 1/4 is 2.25. You could take 1 divided by 4, or maybe you could just think of like kind of like a fourth of a dollar is a quarter. So 0.25. At this point, these are all in decimal form, and so now we're ready to put these in order. Putting them in order, what we need to remember is that our negative numbers, if it's more negative, then it's a smaller number. So negatives kind of work opposite from the positive numbers. So the most negative number here is negative 3.97621, and so on. Negative 2.5 would be the next smallest number in the group then. Now we're to the positives, so 2.25. Actually, go back to what they gave us originally, 2 1/4. Our 3.6 repeating, if it helps you, you can go ahead and put some 6s, other 6s after the decimal there. But basically, looking at our last 2 numbers here, just look at the 10th spot. The lower 10th spot is the 3.31 whatever, which was the square root of 11. And then that'll leave the 3.6 repeating to be the biggest number in that group. So page 22, if we look at the do you understand number 3, it says which is a better approximation of the square root of 20, 4.5 or 4.47. Again, just depending whether we can use a calculator or not. If we're allowed to use a calculator and we do the square root of 20, we get like 4.4721 something. Okay, so looking at it that way, the 4 5/10, that's accurate to the nearest tenth. 4.47, that's to the nearest hundredth. So 4.47 would be a better approximation. Okay, and like I said, that's the nearest hundredth. The more numbers that we have matching up with what we have on our calculator, the more accurate that approximation is. If we look at number 5, they want us to approximate square root of 18 to the nearest tenth and put it on a number line. Again, we could do this even if we didn't have a calculator. It's just going to take a little bit longer. You know, we could pinpoint, obviously it's between 4 and 5 because they're giving us that information on the number line. And then we could just by hand multiply, you know, 4.1 times 4.1 and so on. I'll allow you to use your calculator with this, so square root of 18. So if you do square root of 18 on the calculator, that's like 4.24 something. So that's in between 4.2 and 4.3. So that would be closer to 4.2. Technically, plotting it on the number line, it's technically would be here, but the nearest tenth, if we want to make sure we're answered the question, nearest tenth would be 4 2/10. So this gives you an idea of how to compare and order real numbers.